Welcome to our first video. I want you to imagine that you showed up for math class and you looked around and that there were 6 girls and 2 boys, including yourself, in the entire class. And then later on you went to English class and you noticed that there were 12 girls and 4 boys. Being a person like yourself that notices patterns, what kind of patterns could you notice? I'm just going to rewrite those numbers. Alright, so I put the numbers a little closer together and I wrote the girls in green and the boys in blue. I think you'd notice a couple things. First of all, while the English class is bigger, how much bigger is it? Well, for girls, if you look at it, it goes from 6 to 12, and from boys it goes from 2 to 4. So it looks like whenever you have to go that way, you have to multiply times 2. So there's an interesting relationship. You might also notice that you could kind of go comparison of the number of girls to the number of boys. Maybe that was the first thing that you noticed, that if you took the number of boys and you multiply that times 3, 2 times 3 is 6, you'd get the number of girls, and it works out this way too. So there's actually kind of 2 sets of patterns you can look at. I'm just going to write out the numbers one more time. Is there any relationship or pattern that you can notice when you look at the numbers across from each other? So if you look at, the 6 and the 4, and then later on you look at, say, the 2 and the 12. Can you see a pattern there? If it is, was it that they both multiply out to the same number? 2 times 12 equals 24, and 6 times 4 is equal to 24. That's actually a pretty useful feature that we're going to find out a little bit later on. So we see lots of patterns in here. How could we keep the ratio the same in a class with 9 girls? Well, first of all, we use this word ratio without even saying what it is. So in the next line here I say a ratio is a comparison between 2 quantities or numbers or ideas. So what are the things that we were comparing here? Well, there was 2 kind of comparisons that we're doing. We're comparing, let's say, girls to boys, right? That's the obvious one to look at. So if we how about we restrict our thinking right now just to the math class here, and we'd say, there's a comparison we can make between the number of girls and the number of boys. What are the different ways that we could write these? Well, as a fraction, we could say 6 over 2. Now we have to be careful about the fact that we've got girls on the top and boys on the bottom. So, not always, but you'll notice that sometimes I'll end up actually writing out the units. 6 what? Girls. 2 what? 2 boys. Okay. You could also write it as 2 over 6, as long as you keep track of what we mean by on the top and on the bottom. We would write 2 boys and 6 girls. How about on words? Well, we could say, this is the one way I would like I like to write it. I could say, for every 6 girls, there are 2 boys. What about as a colon? Well, we could say 6 to 2, right? Or we could even write it out, 6 girls to 2 boys. What is the ratio in our math class? That's the one we're doing. In simplest form, well, in simplest form, instead of 6 over 2, it'd be 3 over 1. Written out in words, you could say for every 3 girls, there is 1 boy. Or perhaps, more likely the way we would write it, we could say for every boy, there are 3 girls. So I'm not sure if the boys would like that or the girls would like that. I don't know. Colon, in colon form, we could say, well, 3 to 1. Right? When proportions, what's the proportion? When 2 ratios are equal, they form a proportion. So an example here, we had 6 over 2 is equal to 3 over 1. In fact, our original example, the reason why we got these patterns was because these are proportional. We could say 6 over 2 was equal to, what was it, 12 over 4? 12 over 4. So that these two ratios, here's a ratio on the left, and here's a ratio on the right. When these two are equal, then this whole thing here is a proportion. Another way we can say it is that these are proportional. Now, not everything in life is proportional. Let's take a look at this and we'll answer these questions. We've got 1, 2, 3, 4 questions, and we're going to say which ones of these are proportional, and then we're going to say why they're proportional. The ratio of girls to boys in our example. Well, this was it right here. I just wrote it out. This is our 6 to 2. We had 6 girls to 2 boys, and then we had 12 girls to 4 boys. They are proportional. Why? Because those two ratios, or fractions, however you want to look at it, are equal. How about ratio of girls to boys in real classes? Well, clearly that's not always the case. 6 over 2, I don't know, can you fill in the number of girls we have right now in this class and the number of boys that are in this class? I don't think that these are going to be equal. So are these proportional? No. I guess this one was yes. How about not all of you will have a job. In fact, probably not many yet, but it'll be coming soon. The hours that you work and how much you get paid. Well, let's say that I have a job where I get paid $12 per hour. So if I worked 1 hour, and what I'll do is I'll put it in fraction form. I'll put 1 hour. I would get $12. What about if I worked, say, I don't know, 3 hours? I would in fact get paid $36. So hours worked and how much you get paid, those two fractions are equal. 12 over 1 is the same thing as 36 over 3, so I'd say yes. How about hours studied and the mark that you're going to get on the test at the end of this unit? Well, let's say that if you studied for, I kind of like to put time on the bottom, but it doesn't really matter. Let's say if you studied for 1 hour and you got a 60% on the test, and then you studied for, say, 4 hours, and you got a 90% on the test. Those might be fair, I don't know. But are those proportional? Does it work? Is 60 over 1 the same as 90 over 4? Well, if I look at kind of the patterns we were looking for, if I go like this and say times 4, if I do 60 times 4, I don't get 90. So no, that one's not going to work. Nope. Yeah. I'm going to put it in blue this time. Nope. Can you think of a ratio that is a proportion? Well, I don't know. I know when I go to the deli and I want to order some nice ham or something, it might cost, $2.20 per 100 grams. So I often say, hey, can I have 200 grams, please? So it is proportional, and I think you can probably figure out by looking at the patterns we did before. We say, oh, this is times 2. So this is going to be times 2. So that would be $4.40. Let's see if you can pick up another one. By the way, maybe we should go back to this question that we didn't answer. Maybe some of you are thinking, hey, Mr. Spazio, you forgot. How could we keep the same ratio? How could we keep the ratio the same in a class with 9 girls? Okay, so we started off with 6 over 2. That was girls on the top, boys on the bottom, and then 9 girls, and then something on the bottom. Is there any way we have to figure that out? To figure out how many boys that would be? Well, I guess I kind of like the 2 times 9 is equal to 18. Times 9 is equal to 18. And that's going to be equal to 6 times whatever we put in the box. So I think that would be 3. 3 boys. Cool. Okay, let's take a look at that next page. Okay, so I'm still using an example of a math class. This one's slightly different. I've got 4 girls and 12 boys. It says, how could we keep the same ratio, uh, keep the ratio the same in a class with 6 girls? So if I'll just use this part here. You know, I could say like this, and we're going to have a 6 on the top, 6 girls, and we don't know how many boys, some number on the bottom. So here's one method, and we did it already. Look for a pattern using multiplication or division. So if I go 4 over 12 is equal to 6 over something, well, there's a couple ways we can look for here. That's a tough one to multiply. 4 times something is equal to 6. It's a little bit hard to think of, but you know what? This one works. I could say 4 times 3. And then so I have to do this one too, right? This one times 3. Because it looks like there are 3 times as many boys as every girl, so I'm going to multiply times 3 there. So that would be 18. So I would say 18 boys. I like this method. This is kind of like the quick method, method number 1. I'm calling it method number 1. If you say to somebody else in the street, be like, hey, how do you like method number 1? Be like, well, I just called it method number 1. But sometimes it really only works for friendly numbers. So it's kind of quick, but you really need a method that works even for crazy numbers, right? So if you can't use method number 1, then we got to use algebra. So let's use the algebra here. So we're going to say, I like green, 4 over 12 equals 6 over, now what is algebra? Algebra is like you put a variable in this, we like to use x, you can use any letter you want, in for the unknown, and then you do your math-a-magic, you figure it out. So we're going to use that property that we discovered a little bit later on, a little bit earlier, is that this 12 times a 6 is going to be equal to the 4 times the x. So my next line will be 12 times 6. Now, I like to sometimes put a dot for 12 times 6. You could also do a 12 with parentheses over there. Works either way. Or if you want to, you could say 12 times 6. If you do that, that's fine. Just make sure that your time symbol looks different than your x symbol. And that's going to be equal to 4x. 4x means 4 times x. So 12 times 6 might be a calculator moment here. So we'd say 72 equals 4x, and then we have to get x by itself. So x is not by itself. X is being multiplied by 4. So how do you undo that? You divide both sides by 4, because if I divide this by 4, I'm going to end up getting x, because 4 divided by 4 is 1, and so 1x is x. And if I divide 4 on one side, I have to divide 4 on the other side to keep things equal. 17 divided by 4 is 18. So which way would I do on this one? I would go with method number 1. It's easier, isn't it? But if the numbers were a little scary or you weren't quite sure, you didn't find a pattern, you can always use algebra. Okay, so here's some examples. I'm going to do A, and then I'm going to ask you to hit pause and try B using your calculator. So you're going to have to get a calculator out to try this out. I'm going to use the algebra method here. I'm going to say x times 24, so I'm going to get 24x is going to be equal to 5 times 6, and I happen to know that that is 30. So now I'm going to divide both sides by 24. So I'm going to get x equals 30 over 24. That's not bad, but you know what? A couple things about it is it's an improper fraction, and it's not in lowest terms. So what we're going to say in this course, if we got a fraction, I like fractions, but I'd rather have them in lowest terms. So I can divide both the top and the bottom. I notice here that divide by 6. And this is just optional if you want to put it in lowest terms. So 30 divided by 6 is 5. 24 divided by 6 is 4. So I'd be happy with that as an answer. I would be happy as 1 1/4 as an answer. Ba-ching. Or, and I'm thinking most of you are going to go this route, if you want to get your calculator out and do 30 divided by 24, and what will you get? I think it's 1.25. And all those are perfectly acceptable. If I say, please give me the answer in fraction form, then clearly you don't want to do this one because that's decimal form. So that's good to go. Now, I want you to hit pause and try this one on your own. And try it out, and then hit play again, and then you can check the answer. Okay, so here's what I got. In green is method number 2 with the cross multiplying method, and I get 21. I had to use my calculator on that one because I didn't do 36 times 42 equals 1,512 in my head. Nope, I used my calculator. But I also showed in blue here method number 1 where I did this all in my head, and I thought, hey, I see a pattern. 36 times 2 is 72, or you can say the number on the top is half of what's on the bottom, so what's half of 42? 21. So there you go, kind of cool. All right, so those two examples, you'll notice there's some similarity between A and B in that the X is in the numerator. C and D have switched things up a little bit where X is in the denominator. So I'm going to do C here for you, and same idea. Once I'm done this, I want you to try D on your own by hitting pause and stuff. So if I do the cross multiplying method here, I get 5 times 15 equals 36 times X. 5 times 15, I think, is 75, equals 36x. So divide both sides by 36. And so, I wonder what 75 divided by 36 is. It's kind of a crazy number. When I look at my calculator, I get 2.08, and then the 3's go on forever, so I put that line over there, equals x. You might say, okay, how many of those digits do I need? Well, a little bit later on, if you have some time and you want to, if you're going to reuse that number later in the calculation, it's kind of nice to be able to use your memory to do that, and I can show you on your calculator how to do that. But if it's your final answer like this one, I think generally in this course, if it's in money, then we have to go to the nearest hundredth, right? But otherwise, I think we'll go to the nearest tenth, unless I tell you otherwise. So the question is it closer to 2.0 or is it closer to 2.1? So 2.08, if I kind of made a number line here, 2.08 would be somewhere close to 2.1, because 8 is closer to 10 than it is to 0, if that makes sense to you. So if I round that off, I would say that is 2.1. So in other words, if this number is 5 or greater, we make the 0 a 1. We move that up 1. I'm not sure if there would be really an easy way to do the short method on this one. All right, here is another one. I think you might have to use your calculator on this. I want you to hit pause and then try it out on your own and then press play again to see the solution. So hit pause now. Okay, so here's my solution. I typed in, using that cross multiplying, I got 4x equals 6.2 times 1.3. This was what was on my calculator. By the way, if you've got a whole big thing on your calculator, you wouldn't have to write every single digit down. But what I wouldn't do is I wouldn't hit cancel and then retype the number again. So a little bit of a calculator tip from going from here to here is that after you've done 6.2 times 1.3 and you've got that 8.06 on the screen, at that point you're going to have to divide both sides by 4. So instead of hitting cancel and rewriting the number, just put in divided by 4 and then hit the equal sign, and then it'll save yourself some key presses and you won't have that chance of retyping in the same number incorrectly. And then 2.015, I showed here how I rounded to the nearest tenth. I put 2.0. You could also just say 2 if you wanted to. Okay, and so that's the end of this portion of the lesson, and so I hope that all makes sense to you. In the next video, still the same lesson, I'm going to do a few examples of word problems that have units. So I'll see you later. See you in class.